Hello, this video goes over lesson 12.1 on reflections. This is the start of unit 12, which is a short unit on transformations. Our goal for this lesson is to identify and draw reflections. First, a transformation is a function that moves or changes a figure in some way to produce a new figure. The original figure before the transformation is called the pre-image. We use capital letters for the pre-image like A, B, and C. The image is the new figure that's produced after the transformation. And for the image, you use the same capital letters as the pre-image, but you add a little prime symbol. So we read that as A prime, B prime, C prime. An isometry is a type of transformation that does not change the size or shape of an object. All of the transformations that we're going to study in Unit 12, reflections, translations, and rotations, are all isometries, meaning the size and shape will not change. Isometries are also sometimes called congruence transformations or rigid motions. This section focuses specifically on reflections, and a reflection is a transformation across a line called the line of reflection. So the line of reflection is the perpendicular bisector of each segment joining the point and its image. In simple terms, a reflection takes an object and mirrors or flips it across a line. Let's start by just identifying reflections. We have these different pictures and we want to determine if they're a reflection and explain. First, you can see that in part A, if we imagine like a reflection line right here, the one on the left and the one on the right could just be mirrored over onto each other. So this is a reflection because it's mirrored across a line. For part B, you can see that that is not mirrored. There's nowhere I can draw a line. So this is going to be not a reflection because it's not mirrored across a line. And then for C here, this one is a mirror, but the reflection line is diagonal like that. So this is a reflection because it's flipped or mirrored across a line. Go ahead and try the try now on your own. Does that look like a reflection? This one is not a reflection. To get from one to the other, it just moves over. It is not flipped or mirrored. We're going to talk about that in the next section. The try now is actually a picture of a translation. Now that we know the basics of what a reflection is, let's talk about reflections in the coordinate plane. When you're reflecting across the x-axis, we always draw the line of reflection as a dotted line. So I'm making a dotted line here over my x-axis. And when we flip across the x-axis, the x value of the point doesn't change, but the y switches sides. So it has to switch signs. The rule that we'll use for a reflection across the x-axis is xy maps to x opposite of y. X stays the same and y flips. Next, we have a reflection across the y-axis. And when you reflect across the vertical y-axis, the y value is going to stay the same and the x is going to flip. That makes the rule here, xy maps to opposite of x, y. And we should maybe make note that that negative just means the opposite of y, or in this case, opposite of x. So you're just going to have to flip the sign. It doesn't mean it's always negative. If it starts as negative, it would flip to a positive. And then for reflecting across the line y equals x, that line is already drawn in for us. Notice how the line y equals x goes through the origin, and it has a slope of 1. it'll pass through 1, 1, 2, 2, 3, 3, etc. The rule for a reflection across y equals x is xy maps to yx. So here, the x and the y just switch places. Here I wrote a little note. You can add this if you'd like. By like x-axis, the x stays, y flips, y-axis, the y stays, and the x flips, and y equals x, the x and the y will trade places. We're going to be using lots of rules throughout this chapter. These rules are like the maps. So it's going to be good for you to learn how these rules work. We're going to apply those in our next example. Here, we are given the points A, -3, 4, B, 0, 1, and C, 2, 3. And we want to draw triangle ABC and its reflection across the given line. Let's start by reflecting across the x-axis. Here is the x-axis right here. And when we mirror across the x-axis, the points that are above the x-axis are going to flip to below. You could do this just by counting boxes without the rule. For example, notice how A is 1, 2, 3, 4 above the x-axis, so A prime is going to be the same distance, but 4 below. That makes A prime -3, -4. Similarly, B is 1 above, B prime would be 1 below. And C is 3 above, C prime 1, 2, 3 below, right there. And you can see that my new triangle looks like it was just mirrored, like folded across the line. The X values of the image are the same as the pre-image, and the Y values flip. So I could also just have applied the rule xy maps to x opposite of y. I'll use the rule on the next one. For reflection across the y-axis, this time our ordered pairs xy will map to the opposite of x, y. The x flips and the y stays. Here, that -3 flips to +3, 4 stays the same. 0 we cannot flip, so that one's going to stay the same. And then 1. 2 can flip to -2, and 3. The reason why 0, 1 doesn't change at all is because the point B is right on the reflection line, and that means B prime is also going to be right on the reflection line. A and C, though, are going to move to the opposite sides. A over now at 3, 4. So that's A prime, and C prime is at -2, +3. And there's our reflection. Let's look at one more reflection. This time we're going to reflect a quadrilateral. See how there are 4 points? We're going to reflect it across the line y equals x. Here the pre-image is not drawn, so you're going to have to start by plotting those points x, y. 2, 1 would be here, then 6, 1, 4, -3, and 0, -3. And I do need to label my points. I just like to plot them first so that I can know where to put my letters. This was M, N, P, Q. All right. So now we're going to draw that, and we're going to reflect it across the line y equals x. The line y equals x goes through the origin and has a slope of 1. It's this diagonal line right here. If you just connect the corner of your boxes, that works. And when we reflect across the line y equals x, the coordinates are going to switch places. xy will map to yx. 2, 1 then will become 1, 2. 6, 1, 1, 6. 4, -3 will be -3, 4. And 0, -3 becomes -3, 0. Let's go ahead and plot the points, and if we did this correctly, it should look like it's mirrored across that line that I drew in. Make sure that you are always labeling your points. I usually just put the letters back in after I've connected the lines so that I don't accidentally put them where I need to draw the lines. There we go. That does look like it's just mirrored across. If you were to fold your paper diagonally, the image and pre-image would line up perfectly. You can try the try now on your own. You're going to start with the same quadrilateral MNPQ, but this time you're going to reflect it across the x-axis. Go ahead and pause your video. Then when you hit play, I'll have the answer up. And there's your solution to the try now. This concludes lesson 12.1. Thanks for watching. Bye.